Hi everyone! Welcome to Grade 10 Mathematics Quarter 1, Week 4. Our topic for today is geometric sequence with the learning competency. The learner determines geometric mean, nth term of a geometric sequence, and sum of the terms of a given finite or infinite geometric sequence. We have 4 objectives. Number 1, insert geometric means between two given terms of a geometric sequence. Number 2, we have find the nth term of a geometric sequence. Number 3, find the sum of the terms of a finite geometric sequence. And number 4, find the sum of the terms of an infinite geometric sequence. In this video, we will be focusing on the first 2 objectives only. Okay, so before we begin, let's have first a short recall. Geometric sequence is a sequence where each term after the first is obtained by multiplying the preceding term by a non-zero constant called the common ratio R. We have the formula a sub n is equal to a sub 1 times r raised to n minus 1, where a sub n is equal to nth term, a sub 1 is equal to the first term, r is the common ratio, n is equal to the number of terms. So for your first activity, you are going to answer the problems and you are going to answer the following guide questions on a separate sheet of paper. Okay, so let's proceed. We have geometric means. Geometric means are terms between two given terms of a geometric sequence. We can say that the terms between a sub 1 and a sub n of the geometric sequence are the geometric means. So let's say, for example, we have here insert 3 geometric means between a sub 1 and a sub 5. So you have here a sub 1 and a sub 5, and the 3 terms in between these 2 terms are what we call the geometric means. Okay, so you have here the steps in solving geometric means. Number 1, identify the number of terms in the geometric sequence, which is the variable n, including the first term, last term, and the geometric means, and the other given values such as the first term and the last term. Number 2, we have solve the common ratio, and number 3, we have multiply the first term by the common ratio. Repeat the procedure until all required geometric means are solved. And we have here a note: if the nth root is even, there are 2 roots, positive and negative. Second is, if the nth root is odd, there is only 1 root, either positive or negative. Okay, now let's have an example. Insert 3 geometric means between 8 and 128. So we have here the steps. Number 1, write the given in sequence form. So in this case, we will have the first term and the last term, and in between we are going to have 3 blanks where we are going to insert the 3 geometric means. Step number 2, we are going to determine the number of terms and the values of the first term and the last term. So in this problem, our number of terms, or n, is equal to 5, and our first term is 8, and our last term is 128, which is the 5th term, a sub 5. Okay, so number 3, we are going to solve for the common ratio r by substituting the values of n, a sub 1, and a sub 5 in the formula. So we have the formula, which is a sub n is equal to a sub 1 times r raised to the power of n minus 1. So if we substitute, a sub n is 128, a sub 1 is 8, R is our unknown, and n minus 1 is 5 minus 1. Okay, so next, after substituting, we are going to apply multiplication property of equality. So in this case, we are going to operate first 5 minus 1, where it will become equivalent to 4, and then apply the multiplication property of equality. So in this case, we are going to multiply both sides of the equation by 1/8. Now some of you may ask, why 1/8? So remember, we are trying to solve for the value of R. So to make this possible, we have to divide out this 8 by multiplying to its reciprocal, which is 1/8. So if we multiply on the right side, we should do the same on the left side. Now in this case, we can now divide out 8 such that 1 multiplied to r raised to 4 is equivalent to r raised to 4. On the left side, we have 1/8 times 128. So in this case, multiply 128 to 1 and then divided by 8. So the answer is 16. So we have now r raised to 4 is equal to 16. Next, we have here extract the root. Now, since we have here raised to the power of 4, in order to solve for the value of r, we are going to take the fourth root of each side. So for r raised to 4, taking the fourth root, we will have r. And on the right side, 16 is equivalent to 2 raised to 4. Since 2 times 2 times 2 times 2, 4 times, is equivalent to 16. And that is 2 raised to 4. So, in this case, by extracting its root, we will have 2. Now, since our nth root is even, which is 4, therefore we will have 2 roots, which are positive and negative 2. Okay, so to continue, let's solve first for the positive root, which is positive 2. So for a sub 2, we have the first term times r, that is 8 times 2, which is 16. For a sub 3, we have a sub 2 times r, so that is 16 times 2, 32. And for a sub 4, we have a sub 3 times r, 32 times 2, that is 64. So we have now the geometric means, which are 16, 32, and 64. Now for the negative root, we have r is equal to negative 2. So for the second term, so we have a sub 1 times r, which is 8 times negative 2, that is negative 16. For the a sub 3, we have a sub 2 times r, which is negative 16 times negative 2, that is 32. And a sub 4 is equal to a sub 3 times r, that is 32 times negative 2, equivalent to negative 64. So for the negative root, we have negative 16, 32, and negative 64. Therefore, we can have two possible sequences. So for the first sequence, where the root is positive, we have this. And for the second sequence, where the root is negative, is this. Okay, so this time we can now proceed on example number 2. Insert two geometric means between 3 and 648. So for step number 1, write the given in a sequence form and determine the number of terms and the other given, such as the first term and the last term. So we have here the sequence where we write the first term 3, in between the two blanks for the geometric means, and 648, the last term. So in this sequence, we can identify the total number of terms, which is 4. Our first term, a sub 1, is equal to 3. And our last term, which is a sub 4, is equal to 648. Next, for step number 2, we have solved for the common ratio r using the formula a sub n is equal to a sub 1 times r raised to the power of n minus 1. Okay, so to do this, a sub n, which is the last term, 648. And then we have a sub 1, which is 3, the first term. And then r, the unknown. And then n minus 1, which is 4 minus 1. Next, we are going to apply multiplication property of equality. So, we can see here that the exponent has been simplified already, where 4 minus 1 become 3. So, to apply the multiplication property of equality, we are going to multiply both sides by 1 over 3. You may be asking, why 1 over 3? It's because the reciprocal of 3 is 1 over 3. And it's the only way where we can divide out the coefficient 3 to solve for r. So by doing this, 3 times 1 over 3, we can now divide out and multiply to r raised to 3. So we have r raised to 3. And on the left side, we are going to multiply by 1 over 3 also. So 1/3 of 648 is 216. So therefore, we have r raised to 3 is equal to 216. Now, next step, we have extract the root. Since the nth root is odd, so you can see here, our nth root is 3, and that is odd. This means that we can only have one root. Now we are going to extract the nth root. For r raised to 3, taking the cube root, we can now extract and have r. And for 216, that is 6 times 6 times 6, which is equivalent to 6 raised to 3. Now, taking the cube root, we have 6. Therefore, our common ratio is equivalent to positive 6. Now, we can determine the geometric mean by solving. We have a sub 2 is equal to the first term times r. So, 3 times 6, that is 18. And for a sub 3, that is a sub 2 times r, 18 times 6, and that is 108. Therefore, the geometric means are 18 and 108. And our sequence will be 3, 18, 108, and 648. Okay, so this time we will be moving on with finding the nth term of a geometric sequence. So, as I recall, we have here the formula. So, we will be using the formula in solving for the nth term of a geometric sequence. Example number 1, we have find a sub 10 of the geometric sequence 8, 4, 2, 1, and so on. So the first step is to determine the common ratio. So to determine or to get the common ratio, we just simply divide two consecutive terms. So for example, we have 8 and 4. We are going to divide 4 by 8. So that is equivalent to 1 over 2. And if you take 4 and 2, so you are going to divide 2 by 4. that is 1 over 2. And if you take also 2 and 1, you will have 1 over 2. Thus, our common ratio is equivalent to 1 over 2. Next, we are going to identify the given values for a sub 1, r, and n. So our a sub 1, or the first term, is 8. Our r, which is already 1 over 2, and n is 10. Next, we are going to solve for a sub 10 by substituting the values of the given in the formula. So we have the formula a sub n is equal to a sub 1 times r n minus 1. By substitution, a sub n, which is a sub 10, and a sub 1, which is 8, the first term, and then r is 1 over 2, and then n minus 1 will be 10 minus 1. Next, simplify. 10 minus 1 is 9. By law of exponents, we simply distribute the exponent 9 to the numerator and denominator. So this will become 1 raised to 9 over 2 raised to 9. 1 raised to 9 is equal to 1, and 2 raised to 9 is 512. That's why we have 1 over 512. And then we are going to multiply 8 times 1, which is 8 over 512. Since both numerator and denominator is divisible by 8, so we can divide by 8. So 8 divided by 8 is 1. 512 divided by 8 is 64. Our 10th term, or a sub 10, is 1 over 64. Next, we have number 2. Solve for the 12th term, or a sub 12, when a sub 1 is 6 and r is equal to 1 over 3. Okay, so for step number 1, we are going to skip since the common ratio is already given, 1 over 3. Now proceed to step number 2. Determine the given values for a sub 1, r, and n. So a sub 1 is 6, r is 1 over 3, n is 12, which is the total number of terms. Next, step number 3. Solve for a sub 12 by substituting the values of a sub 1, r, and n in the formula. Okay, so a sub n will be a sub 12, a sub 1 will be 6, r will be 1 over 3, n minus 1 will be 12 minus 1. Next, simplify. 12 minus 1 is 11. And then distribute the exponent 11 to the numerator and denominator. So this will become 1 raised to 11 over 3 raised to 11. 1 raised to 11 is 1, and 3 raised to 11 is 177,147. Next, multiply 6 times 1, that is 6 all over 177,147. Next, simplify, where 6 is a factor of 3 and 2. And the denominator can be factored by 3 times 59,049. So by dividing 3, you will have 2, and then 59,049. Hence, our A sub 12 is equivalent to 2 over 59,049. So next, you will be answering the first two SAQ questions. How do you find the common ratio of the given sequence? It has been discussed. Number 2, write the steps in solving the nth term of a geometric sequence. Okay, very simple. Don't forget to answer on a separate sheet of paper. Okay, so next you will have an activity. So you are going to answer the table. You have to fill in all the boxes on this illustration. And then at the bottom, you are going to answer the questions. And for the second activity, you are going to solve for the nth term. And you have to show your solution. So next, you have the key points, the definition of geometric means, steps in solving geometric means, and the following notes that you need to remember. If the nth root is even, you will have 2 roots or 2 possible sequences. If the nth root is odd, you can only have 1 root, either positive or negative. Next, you have the formula in determining the nth term. So memorize the formula. And then you will have the following assessments. Assessment number 1, finding the missing terms of the geometric sequence, 5 items. Assessment number 2, you have solve for the nth term of the following. So after solving the nth term, you just have to check which is the answer among the choices. 5 items. And assessment number 3, you have choose the letter of the correct answer from the given choices and circle the letter of your choice. So you have 5 items. Okay, so that's it for the first 2 objectives. Thank you for watching. Please like and subscribe.